Hello students. So in this class we will discuss the concept of static members in C++ with the help of a practical. Okay. So what we'll do, we'll just create a program and we'll see the implementation of the static data variable under static members. So I have just created a class STA, and inside this STA I will just create a static variable under this public access specifier. So how I will declare it? I will declare it with the help of a keyword static, okay, followed by the data member. Okay, so for here I am just taking integer as a data type, and x is a variable of type integer that has been declared as static. So this is the declaration part. Okay, this is the declaration of static variable. We can't define static variable here, okay, or you can say we can't initialize static variable inside a class. This is a rule in C++. So in order to define this static variable, we have to use, okay, certain syntax, and we have to define, or you can say we have to provide the memory to this variable x outside the class. So it will be done with the help of a syntax, that is the return type of the static variable, that is int, the name of the class, that is sta, followed by the scope position operator and the name of the variable x. Okay, so now this is defining of static variable. Okay, so this step is very important. So whenever you are creating a static variable, okay, through class, so you have to initialize the static variable outside the class with the help of this particular syntax. So now by default the value of this static variable x is 0. That has been, okay, initialized by the compiler because we haven't assigned any value, but we will explicitly assign some value to this static variable also later in our program. So now we will just try to access this static variable. So we will just create a main, okay, and inside main we are just interested in creating an object, though static variable doesn't depend upon the object's creation. Okay, so if we don't want to create the object, then also this static variable will be present in our program. Okay, then also we can access this static variable. Okay, so the object creation is not compulsory, but okay, we can access it with the help of object also. Okay, so we'll just create an object st, and we'll just see that if we type cout, okay, st.x, then what will be the output of this particular code. So as you can see here, this static variable has been declared in this public section, so it can be accessed, okay, outside the main, and as a result of which this particular statement is valid statement. Okay, so if we try to run this particular code, then the output will be 0, okay, the default value that has been, okay, set by the compiler, because we haven't assigned or we haven't initialized any value to this variable. So there will be no garbage value printed. The value that will be printed is 0. So let's try to run this. There is some error in this code, and the error is sta was not declared in this scope. Why it is showing the error? Because the class name starts with first letter capital, and here we have just written the letter as small. So this is a blunder we have committed, but not a problem, because through errors we will be understanding the program. Okay, so now let's try to run this and let's check. Okay, it has been successfully compiled and run, and you can see the output here is 0. Okay, so it means that this variable has been successfully, okay, assigned a value 0 by the compiler, that is the default value. Now we can explicitly also, okay, initialize some value to this static variable. So how we can initialize it? We can just write, okay, any value. Let us suppose if I write 100 here, so now what the output will be, this 0 will be overwritten by this 100. Okay, so the new value will be now 100, that will be shared with this particular object. Okay, so if we try to execute this, so now the output will be 100. Okay, so the value of x will be 100. So here you can see the value of x is 100. Okay, so you can also, okay, you can also write the value here also. Okay, so you can also write it as x equal to 200, so it will also work. So now this 200 value will be the most updated one, so it will replace this 100. Okay, so now this 100 will be replaced, or you can say overwritten by this 200 value. So now the object will be shared, okay, a value that is 200. So let's try to execute this, and you can see the current value is 200. Okay, so in this way we can use static variable. Okay, but okay, the next question is, if I try to, let us suppose, create an object. So if I try to create an object st1 and again I try to create an object st2, so now what happens, we have created two objects. Okay, so if I try to access, okay, or I can say if I try to initialize some value, for example st1, okay, dot x equal to 300, if I write, and if I write st2 dot x equal to 400, for example, any value I have, okay, initialize it with 300 and 400. These are some random values that x will be initialized. So if I try to just print, okay, st1 dot x, and I just give it a new line here. Okay, so this is endl, and in the next line if I just write cout st2 dot x, so can you tell me that what will be the output now? Can you guess that what will be the output of this particular code? Because now what we have done, we have initialized, okay, this static variable as 100, and now we have further initialized this static variable for object st1 as 300, and for object st2 this variable has been initialized as value 400, and now we have printed the value of st1 and st2. So the output will, okay, be something like, it won't be 100, okay, it won't be 300, the output will be 400. Okay, so let's try to check the output. So it has printed 400 two times. Okay, so it means that, okay, it means that this 400 value, okay, this 400 value is the most updated value. Okay, this 400 is the most updated value of the static variable x, and this value has been shared by the both the objects. Okay, so this 400 has been shared by both the objects st1 and st2. That is the definition of the static variable, that this static variable, okay, cannot contain multiple copies. Okay, multiple copies can't be exist in for this static variable. All the static members shares same copy, okay, among all the objects. Okay, so the same copy, or you can say the same value, that is the common value 400, has been shared to both these objects. Okay, so the most updated value is 400, and this 400 value has been shared to st2, and it has been also reflected to st1. So the updated value of st1 is not 300 but it is 400. Okay, so I hope it is clear now. Okay, now, okay, what if I don't want to create any object, okay, in my class, okay, and I want to access this static variable, because static variable doesn't depend upon the creation of objects. Okay, this also is true. So I don't want to create the object st1 here. Okay, so how can I access the static variable with the help of class? So what I'll do, okay, so the syntax that I'll be writing, okay, the syntax is, if I want to access this variable x without any object, then we have to write, okay, cout, because I am printing the name of the class sta followed by scope resolution operator and the name of the static variable. Okay, so this static variable, okay, is a class level variable, and this scope is telling that this static variable is an attribute of this class. Okay, so in this way we can access, okay, static variable without n. So a static variable is also known as a class variable. So I just write class variable here. Okay, so I hope now it is clear to you. So let's just try to compile this and let's see what is the output. So it has been compiled successfully, and you can see that the output is 100. It means that without the creation of object we can access this static variable. Okay, we have accessed this static variable, okay, without the creation of any object of the class. Okay, we can access this directly with the help of a class. Okay, directly with the help of a class name we have accessed this static variable. That's why this static variable is also known as a class variable or a class level variable. Now what if I want to create this static variable in a private, okay, in a private section? So here we have just created it in a public section, but if I want to create this static variable in a private section, then how can I access this static variable outside the class? So in order to access this static variable outside the class, okay, we will just use the first concept, that is we have to create an object, and with some member function of this class we can access the static variable, because we have no choice. Okay, so we will just try to create some object and try to access this with the help of an object. Okay, so I just create an object sta and I just write st, but in order to access this X, I have to create a member function. Okay, so a member function must be created in a public section, and let us give it a name as, let us suppose, get X. Okay, and I'll just print the value of this variable, that is the static variable X. So here you can see that this getX is a non-static member function. Okay, and non-static means it is a, you can say, plain member function. It is a normal member function. It doesn't qualified with any static keyword. And here you have, okay, accessed a static variable. So the second point, that a static variable can be accessed inside a non-static member function. So you can write static variable, okay, can be accessed inside a non-static member function. Okay, this is also a property. So what I'll do, I have to invoke, okay, I have to invoke this member function. So I'll just write st dot get x. Okay, so when I just try to compile this code, so the value 100 must be printed. So let's try to execute this code. Okay, so this code has been successfully executed and it has printed the value as 100. Next we can see, okay, if I just, okay, if I just want to assign, okay, any variable. So if I want to assign any variable, any value, okay, from this member function, so we can also do it. Okay, if I just assign 40, then what I have to do, I have to write some, okay, create some local variable inside this. So I just create k and I just assign, okay, k equal to, sorry, x equal to k. So when this value, then this function will be called, so this particular, okay, actual parameter will be, okay, copied into this formal parameters, and the value of k, that is 40, will be assigned to x, and the value of x will be printed. That is the most updated value of x is 40. The 100 value will be overwritten. Okay, so this 40 will be, you can say, it will override this 100. So let's try to compile this. So now you can see that the output is 40. So the 100 value that was previously we have assigned, it has been replaced by this value. Okay, so we can also do it like this.